Good day, my beautiful subscribers and non-subscribers who are yet to subscribe to my channel. Today, I want us to learn physics. I want us to learn about fundamental and derived quantities and units. What are fundamental units, or what are fundamental quantities? Fundamental quantities are those quantities that do not depend on other quantities for their existence. For examples, examples of fundamental quantities are examples of fundamental quantities are, we have the first one, we have the temperature, we have the length, we have mass, we have temperature, length, mass, we have luminous intensity, temperature, length, mass, we have time, we have moles, number of moles, etc. We have many of them. So these are what? These are the fundamental quantities because they do not depend on other quantities for their existence. So we have the length, we have the mass, we have the luminous intensity, we have the time, we have the mole. Mole, which is the amount of substance. Yes, the amount of substance, amount of substance. So we have the amount of substance, etc. So these are the fundamental quantities. What are fundamental units? It is still the same thing as fundamental quantities. Fundamental units are those units that do not depend on other physical quantities for them to have their own units. So, example, the unit of temperature is what? Is a fundamental unit, which is Kelvin. That is the unit of temperature. The length is what? In meter. We have the mass, that is kilogram. We have the luminous intensity, which is this one is a candela. We have the time, that is second. We have amount of substance, that is mole. Then it is. So these are examples of what? Fundamental units. And these are examples of fundamental quantities. Now let's look at derived quantities and derived units. Let's look at them. This thing has written my board. Oh my god. All right, let's look at derived quantities. From the word derive, you should know. Derived quantities are those quantities that depend on the fundamental quantities. Derived quantities, derived quantities are those quantities that depends on the fundamental quantities for their existence. Examples of derived quantities are examples of derived quantities are, we have the velocity, which or speed. You know, the reason why we say that velocity is a derived quantity is that for you to have this velocity, remember that velocity is equals to v is equal to what? Displacement over what? Time taken. So if you look at this one is the fundamental quantity. So it means that velocity depends on displacement and time for it to exist. So without these two guys, you won't have what? Velocity. So in this case, you say that velocity is what? Is the derived quantity. Now we also look at acceleration. Acceleration is also a derived quantity. You also look at area is also a derived quantity. You also look at the volume is also a derived quantity. We also look at pressure is also a derived quantity. We have many of them. So these are examples of what? Derived quantities. Let's look at the derived units. Derived unit is also what? There is also the quantities that derive their unit from the fundamental uh, quantity or unit. So for example now, for velocity, let's look at this. The unit of velocity is what? Meter per second. How come about it? Remember that displacement is measured in meter. So this is meter, then time is measured in what? Seconds. Divided by what? The seconds. So we now have that V is equal to what? Meter per seconds. So it means that we use this formula to derive the unit for what? Velocity. So in this case, the unit of velocity is what? It's a derived unit. It is not CARICOM. So that is why we say that meter per second is the derived unit for what? Velocity. The same thing with acceleration. If you look at acceleration, A equals to what? V over what? T. What is the unit of V? Is what? Meter per second. T is what? Seconds. So when you remove this sign of equality, you are going to have meter per second square. So it therefore means that the unit of acceleration is what? Is a derived unit. So because we have it from velocity over what? Time. And the unit of velocity is the derived unit. Then we also from here we have the final answer to be what? Meter per second. Even the area is what? Length times what? Breadth. Length times breadth. So this length is measured in meter. Breadth is also measured in what? Meter. So when you multiply these two together, you are going to have meter square. So it means that the unit for area is a derived unit, which is what? Meter square. The same thing with pressure. Pressure equals to what? Force over what? Area. So what is the need for force? That is Newton divided by what? Meter square. So P can also equal to now Newton per meter square, which shows that the unit for pressure is a derived unit. So that is how to differentiate between fundamental quantities and derived quantities. Then their units. It is very simple. So this is where we are going to stop in our today's physics class. In our next class, we are going to look at some other thing. Please don't forget to subscribe. Don't forget to share this video. Bye bye.